Hello everyone. So this is our 11th lecture in the series of SolidWorks tutorials. So in this today's tutorials we discuss about the number of other commands such as ribs, shell and draft. So let's start with a new project. So click on new, click on the part and select OK here. As you can see, our sketch window or user interface is open. Now select the plane to draw some element here. Select the front plane, select the sketch toolbar, click on sketch command. Let me draw a center rectangle here first and give the smart dimensions to the rectangle as length of 200 mm and width as 100 mm. As you can see, your sketch is fully defined. It is black in color. So exit the smart dimension command, click OK, exit the sketch, go to the features, select the extrude boss and give the depth of about 50 millimeters, click OK. Now here your billet or blank is ready. Now in this we apply a shell command. So let me first off this perspective view. Now you can see easily, this is your billet or blank. This is your component in which I want to apply a shell command. So shell command, why shell command is used? Now shell command is used to remove the material from inside the body, or you can say that it produces hollow body and removes the internal material from the body. So while now this structure or this component is solid structure, as you can see in the cut section, I can show you that this model is solid right now. See, it is solid from inside and it doesn't have any voids or any vacant space inside it, or you can say any hollow, or you can say any material is removed from the inside of this component. Now I want to apply shell command with certain thickness to it, or and I will show you the command how it is applied by removing certain faces. So when I go to the shell command, as you can see in the feature toolbar, here is our shell command. Shell command is used to remove the material from the solid body to create a thin walled surface, or you can say that it produces a hollow structure inside. So let me apply a shell command here. So I click shell here. You can see in the property manager number of parameters are shown. So first parameter is the depth. It means how much thickness you need while applying a shell command. So when you click shell, your command is applied. You didn't show you can't see that how shell is applied. So just click here, show preview. Now when you click show preview, you can see a yellow structure appears. This means that the shell command is applied and this yellow structure is the structure from where the material is removed. It means that it is hollow within these yellow line limits. Okay, so when you click on shell, the shell commands automatically apply on the component. Now to preview that command, you have to click the show preview option here. Okay, so this is how your shell command applies. Now comes to the thickness or depth thickness part. So that means you have to provide the thickness as per your requirement. By default it is 10. If you want 15 or 20, just click type 15 here. You can see your shell command is 15 from each side, from horizontal as well as from vertical distance. So when you apply 10 here, and then it will be 10 from each edge or surface. Okay, so this is how your shell command apply. When I click OK, you can see the shell commands applied inside the component, as the component is solid from the outside but it is hollow from inside. So to see the shell command applied, just click here the section view and you can see, click OK, a command is applied here. See, the material is removed from the inside and the thickness of the shell is 10 mm from each end, from each edge, from this side, from this side, from this and from this side. So all the thicknesses are constant and it is 10 mm as per the design requirement or as per the input value which you provide previously. Now click off to the section view, go to the shell, right click and click on edit features. Now As you can see, the command is applied here. Now if you want to remove certain face to see whether the command is applied or not, so just click this blue box. This is used to remove faces. So let me click here and click this face. I want to remove this face so that I can see whether the command is applied or not. Okay, so I just click OK here. So this is how your command is applied. You can see easily the solid component becomes a boxy structure and it is hollow inside from inside. So it appears to be like a drawer like structure. Okay, so you can put anything in this. It's all material is removed with a thickness of 10 mm from each side. So this thickness can be varied. You can put the value as 10, 20, 30, 40 as per your requirement. Okay, so this is how your shell command applies. Again, go to the shell, click on edit features. Now if you don't want to remove any face, just click here clear selection, so your structure becomes solid again. Okay, and you can see the shell command with the help of section. Now if you want that in shell command, you have different thicknesses. First option is that you have a constant thickness of 10 mm from each side. But if the drawing or design requirement is that your shell thickness is varied, that it is 10 mm from some other side and 15 mm from other and 20 millimeter from other side, so what you have to do, you have to just click here this multi-section option, thickness settings here. So just click here and select the element or the face to which you want to increase the thickness of beyond 10. So let me click this surface and put the thickness as 15. So you can see easily in preview that this side is 15 mm, this side is 10, 10 and 10. Okay, again if you want some other face or other side to have a more thickness, just click here that other side, put the value again 20, click enter. So you can see from this side it is 20, from this side it is 15, and from these two sides it is 10. So this is how you can provide the multi-shell thickness. Previously we discussed about the constant shell thickness, that it remains 10 from each side, but if the design requirement is such that your two sides are of different variation of thickness and the two sides are of same thickness, so these two sides are 10 mm and this is of 15 mm and this one is of 20 mm. So this is how you can provide the multi-thickness settings in the shell. Now when I click OK, you can easily see that a surface, on the surface, that this thickness is 10, this thickness is 10 and this thickness is 20 and this thickness becomes 15. So this is how you can easily differentiate between the various thicknesses when you apply the shell command. So shell command is nothing, it's just to provide the hollow structure inside the component, or you can say remove the inside material from the component. You can vary the thickness, you can keep the thickness constant also, and you can vary the thickness as per your requirement. So this is your shell command. Now moving to the other command, that is called rib. So before going to the rib command, let me edit some features in the shell command. Let me clear all these selections. It should be 10. Clear the selection, and I can remove all these faces from this side. Click OK. So see, this channel section is created with the help of shell. Or another method is that you have to create this section first, this C, and then extrude it to the back side of the screen. You can also create this section by extrusion or by extrude boss base. With the help of shell you can create this section also. Okay, so now comes to the another command, that is called rib. Now rib, what is rib? Rib is basically a structural element which is used to provide the support to the structure. You can see rib in various pillar structures where we have a hoarding on the roads depicting the areas, depicting the city name, and the pillar is founded having a foundation in the ground, and in that foundation we have a rib structure. You can see a triangular plate is attached to it to provide the support to the pillar. Also you can see rib structure in the bridges and your various steel buildings, where your internal structure of the building is steel structure with the help of girders. So when you join two girders at 90 degree, you provide a rib structure and you put rivet in it. So it is just to provide the support to the steel structure. So when you draw, how to draw a rib in this software? So rib is nothing, it's a support structure to the element. As you can see the icon, so it's a thin walled support to the solid body. Okay, so how to draw a rib here? Now to draw the rib you must have a sketch first. Okay, you can't draw a rib directly to the body. Before that you have to draw the sketch. So sketch should be a line which is inclined to a certain angle or a certain distance. Okay, so let me choose the plane first. So select the right plane. I want to draw a rib between here, at the mid point of these, or mid plane of the surface. Okay, so that's why I select the right plane, click on the sketch, go to sketch, control it so that your component will move towards you, and let me click or select the line option here, click here and draw a line like this. Now provide certain dimension to this. Let me have this dimension as 5 and this dimension as 35. Okay, now see your sketch is fully defined, it is black in color. Escape the font dimension option, click OK, exit the command. Okay, now this is the structure. So this is the structure which produces the rib. Okay, so before drawing the rib you must have a structure, you must have a sketch, so that rib can be applied. So go to the feature toolbar here, click on the rib. Now when you click on the rib you can see a rib is applied. So rib is of two types. First one, that rib is applied when the your sketch when your rib structure is parallel to the sketch. Now in this case your rib structure is yellow in color and your sketch is blue in color. Okay, so your rib is parallel to the sketch, so it has 0 degree with the sketch. And another option is that your rib is 90 degree to the sketch. So this yellow structure is your rib and this line, blue line, is your sketch. Now you can see the rib is 90 degree, preparing an angle of 90 degree to this sketch. Okay, so in this case you have to make sure that you select the first option, that your rib structure is parallel to the sketch. Now another important thing, that your direction of rib, arrow. Now rib will always applied when there is certain material in front of the rib structure. Now you can see the direction of arrow depicts that there are certain material in between. We have a walls, we have a floor here, so rib can be easily applied. Now when I just reverse the direction of arrow, you can see rib cannot be applied. Why? Because all this is airy, or you have a space here. Okay, and rib cannot be applied when there is no material available on the other side of this. So that's why make sure your arrow will be in the direction where there are certain material is available, like wall, floor, or any other material or any other component which is available, so that rib can be propagate from this point or this line to the end of to these walls or floor surfaces. Okay, then third option, rib can have number of thickness options here. First one is that you want rib in the left hand side direction of the sketch. You want rib that is divided on both sides of the sketch with equidistance. If it is 10 mm, then 5 mm in the left, 5 mm in the right. And the third option is that you want a rib of 10 mm in the right hand direction. So it depends upon you that how much what are your drawing and design requirements. According to that you select this thickness option here. So I select the midway option, in which the thickness of the rib is divided in equidistance, that if it is 10, then 5 and 5 on both sides. You can change the value from 10 to 20 also, no issues. Then it would be 10 from left and 10 to the right hand side of this structure. And you click OK here. So your rib structure can be created. You can easily see that your rib can be prepared. When there is a material available, your rib will propagate towards the material. If the rib structure, your direction of the rib is in the upward direction, there is no material available, there is only space. That's why the rib cannot be propagated and it is not built, and the error is shown. So this is how rib can be created. Now rib is nothing, it's just a support element to the structure. Fine. Now the next part of the rib is that when you apply the rib with the 90 degree or normal to the sketch. So what I do, I just select this surface and go to sketch, click on sketch command, control it, and select this spline to create certain element here. See, this is the structure I apply. Now I want to create a rib structure with the help of this sketch. Okay, now what I do, I go to exit the sketch, select the feature toolbar, go to the rib command. Now you can easily see that in this case rib is parallel to the sketch. The rib structure is yellow in color, your sketch is blue in color, and it is parallel to the sketch. Fine. Now if you want this rib to be created, it must be normal to the sketch. See, this is your blue structure of the rib, your sketch, and yellow lines are the structure of the rib, and they are 90 degree to the structure. Now this rib can be created as such. We have a direction in downward direction. As such, we have a material in this side like walls, floors, and again wall. And if I just flip this direction, as you can see, there is no material above this structure. It is all space and air, so rib cannot be applied in this direction. Rib only applied in the direction where the material is available, so that it can propagate downward direction. Now I choose 20, let it should be 10, and you can choose any thickness option from here. And when I click OK, you can see the rib is applied. So this is how you can create a rib when the rib is normal to the plane. And this is the first option, is that when the rib sketch is parallel to the rib structure. So these are the two options by which you can create the rib. Okay, so this second option of rib can be used when you create a baffle structures, and in the boilers or any other condenser equation structures, you can create this, or you can create in the your tumblers also, where you have to distribute the material or you apply certain materials from other materials. So for that you can create this type of rib structures. Okay, so this is how you can create a rib when the rib structure is perpendicular or normal to the sketch, and this is the first option when the rib structure is parallel to the sketch. So this is how you can create rib. So we discuss about the shell, we discuss about the rib, and lastly we discuss about this draft option. So let me quickly go back to my blank position first before applying the shell, like this. Now exit the sketch, feature, extrude boss base, select the sketch, let it be 50, click OK. So this is how you can create the billet. Make sure your perspective condition is off here. So this is how you can create this sketch first. Now then you have to create a 3D element with the help of that rectangular sketch. So now apply draft. Now draft is nothing. Draft is basically used to provide a certain taper to the surfaces of the component so that it can be pulled off from the mold or cavity easily. Okay, when you now draft is widely used in casting and your foundry or in plastic or injection molding or blow molding machines. Here your component is tapered, your sides of the component, let us say this is the side, this is another side, and this one is another side. So these have 4 sides, 1, 2, 3 and 4. These sides are to be tapered to a certain angle. It should be 1 degree, 2 degree, not more than that. Okay, so 1 to 2 degree variation can be seen. Now for the tutorial purpose I will show you about 10 to 20 degrees so that you can easily see that draft can be applied. Okay, so draft is nothing. It is used to provide the taper to the surfaces, or you can say vertical surfaces of the component, so that can be easily removed from the cavity or the mold or from the or cavity of the mold. Okay, fine. So this is how you can provide the draft. So click on the draft. As you can see, a draft parameter is open. Click on manual. Okay, so first of all make sure these are the certain properties of the draft when you apply the draft. This is the component, it has 4 vertical faces, so we apply a draft on these 2 faces. First of all we have to select the neutral plane. So neutral plane is nothing, it is a plane on which your draft your dimensions will be remain same while applying the draft. So let me select this as a neutral plane first. So when I select the neutral plane, this is pink, shown in pink color. that means the dimension of this neutral plane remains constant. If it is 200 in length, it remains in 200. If it is width is 100 mm, then it remains in 100. It doesn't change its dimension, doesn't change its characteristics. It remains same as it is one previously. Now I have to select the faces to draft. So I select this face, I select this face. Okay, I select these two vertical faces for which I have to apply the draft. So draft angle, how much draft do you need? So by default it is 1 degree. You can choose 10, 20. Let us say I apply 20 degree. Now for showing to you in this tutorial, that's why I apply 20. In real life situation, it should be not more than 2 to 3 degree. Okay, so that much draft is applied as per the drawing requirements. Okay, so when I select your neutral plane, after that I select the faces on which I need draft. Make sure you see the direction of the draft. This direction will discuss whether the draft is positive or whether the draft is negative. Okay, so if the direction of the arrow is in upward direction, then draft will be positive. That means your vertical surfaces will move outwards. Okay, will move outwards from their initial positions. So when I click OK here, you can see the vertical surfaces move outwards. See, this is the vertical surface which moves outwards, and again this is also vertical surface which move outwards. So this is how you can define the positive draft. Positive draft occurs when the direction of arrow is in upward direction. So this one is your neutral plane. It remains of same dimensions, 200 by 100, but as you can see, your draft, when you apply the draft, your dimensions for the lower surface will be different as it moves outwards in outward direction, and we apply a positive draft here. Now again go to the draft, edit features. Now what I do, I just reverse the direction of arrow. Now what happens? When you reverse the direction of arrow, your draft will be negative, and the draft your vertical surface will move inside from their initial position. So when I just click or flip this arrow and click OK, see what happens. See what happens. Your draft will move towards, or you can say moves inside from the vertical surface. So this is how you can apply the negative draft. So this draft is known as negative draft. So when you apply positive draft, the direction of arrow will be in upward direction, and the direction of arrow is in downward direction. You apply the negative draft. So draft is used to provide a taper vertical surface so that it can be pulled off easily from the core or the cavity or the mold. Okay, this can be widely used in casting and forging, as well as injection molding and blow molding structures processes. So this is how you can provide the draft. So today we discuss about ribbed, shell, draft. So these are the 3 important commands we discussed today. I think these commands are enough for today's lecture. So I think this lecture to be now concluded, and you must see my previous videos to learn about the various other commands which I uploaded on my channel. So thanks for your support. Thanks for watching.